The mechanical seal is an important component of the pump. It is also a wearing part. Mechanical seals generally come in 3 types. One is this, it's a metal spring, this kind. There are 2 kinds of this kind. There are also 2 kinds of metal spring types. There's also a type called container. The advantage of the container type is that it is more convenient to disassemble. It is more convenient to repair, but the downside is that its cost will be higher. There's another, if you don't want to change the whole, once the whole part is broken, the whole thing has to be replaced. What about the third one? It's called bellows. Why is this called bellows? Because it has this in it. When the spring of the tube is pressed inside, the rubber inside it is concave inward. It acts as a seal. The mechanical seal. There are about 3 types of mechanical seals alone. So what is the principle of the original mechanical seal? So let's take a look at water leaking out. There are 3 directions in total. One is an axial outflow. One is along this steel rings leak out. This one between the gold ring and the pump case, the sealed place leaks out. Another way is to leak out from the sealing surface between the Tokyo rings. Well, in fact, the chance of leakage in the axial and static ring directions is very small. Most of it leaks from the mechanical sealing surface. So this one in the mechanical seal, so we can take a look. You can see the axial direction from the design of the mechanical seal. First of all, we can see that there is an O-ring on the inside of this mechanical seal. This O-ring is thinner than the one on the pump shaft. Plug it in like this. After this is plugged in, then the water that goes towards it will leak out in this direction. So what about the steel ring? There is an O-ring here stuck on this pump case. Water doesn't leak out here. Then in the end, the sealing surface is left. This place, we can see the sealing surface. It's actually the static and dynamic rings are actually disengaged. This is a moving ring. It's a static loop. The static and dynamic rings are disengaged. So how does it get a seal? You can take a look. This aspect is actually we can open it up and take a look. It's reflective. It's very bright. The principle is to use the water itself to act as a seal. So it's called a water breeze. The same is true of the water breeze. With the right amount of water, dynamic ring in one, driven by the pump shaft. This is the moving ring rotating under the drive of the pump shaft. That forms a water film. It forms a film of water between the hydrostatic rings. So that water does not leak out of this sealing surface. That serves as a seal. So this is the fault that the previous seal is often here generated between dynamic and static loops.